These are your Integrated Math 2, Module 4, Topic 1, Lesson 4 notes. This is video 3 of 3. And our learning targets on this video are I can solve a quadratic equation using completing the square method, and I can find the roots or the zeros of a quadratic equation using completing the square method. So example number 1 says solve x squared minus 6x minus 1. So we discovered in class is that sometimes we get quadratic equations like this that are not factorable. So if I went to try to factor this, I would go, okay, I need two numbers that multiply to -1 and add to -6. And that would not be possible. So we couldn't factor it. Then you're thinking, oh, maybe we could use the square root method we learned in class. But wait a minute. We have a b value that's not 0. So remember, we can only use the square root method in standard form if this is 0x. We don't have an x here, right? Then we can do the square root method. So we're out of luck. So we learned another method, and it's called completing the square. All right, so what we're going to do on this is, the first thing we're going to do is we're actually going to take that -1, we're going to move it to the other side. So we're going to add 1 to both sides. And we're going to get x squared minus 6x, I'll leave some space here, equals 1. All right, so to complete the square, what we're going to do is we have ax squared plus bx. And to complete it, we learned in class, we discovered that it's going to be the b value divided by 2 squared. All right, so my b value is -6. Half of -6 is -3. -3 squared, -3 times -3 is positive 9. Okay, now this is an algebraic equation, so what you do to one side of the equation, add 9 here, I must also add 9 on this side of the equation. Okay? So why do we do this? Well, we learned this makes it when you complete the square, we make a perfect square trinomial. And we learned in class, oh, if I factor this, I'm going to get this to become x minus 3 squared. I get a binomial square. So I'm going to get this, x minus 3 squared equals 10. Okay, I added the 9 to this side, and then I factored this. So I'm not showing you all the detailed factoring, but you could do a diamond problem with a generic rectangle. Factor this, you get x minus 3 times x minus 3, which is this. All right, well, we learned how, now we know what we're to do. This is a binomial square. We already learned how to solve these, right? We can take the square root of both sides. So I'm going to take the square root and the square root. When I do that, I take the positive and the negative root. Okay, this becomes just x minus 3 equals plus or minus the square root of 10. And then I want to add 3 to both sides. Be careful, I can't add it with the square root of 10. So I'm going to say plus 3 here, plus 3 in front of the plus minus. And I get x equals 3 plus or minus the square root of 10. That is the exact solution. Okay? If I want the approximate values for this, well, square root of 10 is about what number? Yeah, it's pretty close to 3. It's a little bit bigger than 3, so 3.1, right? Square root of 9 is 3. Square root of 16 is 4. So it's 3.1, 3.2, somewhere in that range. I'm going to call it 3.1. So we get x equals 3 plus minus 3.1. So then what are our answers? X could equal 3 plus 3.1, which is 6.1. And x could also be 3 minus 3.1, which would be like -0.1. Okay, those are your two answers. All right. We will also see this with these types of equations. Whoops, wrong slide. We'll see them where it says find the roots. Okay, so f of x equals x squared plus 12x minus 3. First thing we do is we change f of x to 0 because we're trying to find the roots. They're on when y equals 0 or f of x equals 0. So 0 equals x squared plus 12x minus 3. All right. Now, we may try to factor it first, so we can do factor ZPP. But if I look at this, I got two numbers that multiply to -3 and add to 12. Again, it's not factorable, so we're out of luck. And again, we can't do the square root method because the b value is not 0, the b value is 12. So we're going to have to use this method. All right, so let's do it. We're going to add 3 to both sides, so I'm going to say plus 3 plus 3. And we get 3 equals x squared plus 12x. All right, let's complete the square. Half of 12 is 6. 6 squared is 36. So I'm going to say plus 36, and I'm going to add 36 over here as well. All right, 3 plus 36 is 39, equals this trinomial, but I'm going to factor it. If I factor it, I'm going to get x plus 6 times x plus 6. So I'm going to write that as x plus 6 squared, my binomial square. All right, so now we're going to take the square root of both sides, so plus minus the square root of 39, square root of this. So we're going to get x plus 6 equals plus minus the square root of 39. So I want to solve for x now, so what do? That's right, I'm going to subtract 6 from both sides. So I get -6 plus minus the square root of 39 equals x. That is the precise solution, right? -6 plus the square root of 39, -6 minus the square root of 39. If we want the approximate value, well, then I'd say, what's the square root of 39? 36 is 6, square root of 49 is 7, so maybe it's a lot closer to 6 than 7, so maybe 6.2, 6.3. I'm going to call it 6.2. All right, so we're going to go x equals -6 plus or minus 6.2. All right, and so then I'm going to get x equals -6 plus 6.2 would be 0.2, and x would also equal -6 minus 6.2, so that's what, -12.2. So those are my roots, or my zeros. If I want the x-intercepts, it'd be 0.2 comma 0 and -12.2 comma 0. That's where the parabola would actually cross the x-axis. All right, so that's it for completing the square. The one thing I am going to say about this is this method, we're only going to use it in this class when the a value is 1 for the x squared. It can be done when you have a value other than 1, but it becomes a beast of a problem to do it that way. And so we'll have another tool that we're going to learn here quickly that we'll use in those cases. So we'll only do completing the square for 1x squared problems when we can't factor them. Okay? That's when we'll use this tool. All right. Thanks for taking your notes. That wraps up this topic, or this section of the topic 1.